We'll cover testing a claim about a mean and testing a claim about a standard deviation or variance. A single mean, a single standard deviation or variance. We start with the example we did in class. It's on your handout. The claim is that the mean weight of airline passengers, including carry-on baggage, is at most 195 pounds. Well, that at most is very important because it tells us that we're going to end up with a or equal to. So it's less than or equal to, because at most means that the most that the weight could be is 195. Could be less, but it can't be more. So the claim is that the mean is less than or equal to 195. And that is going to be our original claim, and it's also going to be our null hypothesis. Well, then that means that the complement is our alternative. The complement is the mean is greater than 195. And you see here I've got noted that the original claim is the null here. And since the inequality symbol in the alternative points to the right, we have a right-tailed test. Now we have a sample size of 36, which means that our degrees of freedom are 35, and we need that to look up our critical value. And we have a right-tailed test, so that means that all of the alpha is in one tail. It's in the right tail. And let's see how we find that critical value. Because we are testing a claim about a mean, we will look this up on the t-distribution. And so that's going to be right here. And remember, all of the area is in one tail, and all the alpha is in one tail, and so that alpha is 0.05. And so we'll use that column, the fourth column, and our degrees of freedom are 35 because the sample size is 36. And so that means that right here in this fourth column and in the row with 35 degrees of freedom, we find a critical value of 1.69. Now we need to calculate our test statistic, and it's done with this formula here, which I was shown on the last a page that had the table that I just showed you. And so our sample mean is 202, and so that's what this is, sample mean. It goes right here. And the population mean may or may not be 195, but that is what is named in the problem, 195, and so that's what we assume. So we put 195 for the population mean right here. And then our sample standard deviation is 25, the sample size is 36, so those fill out the rest of the calculation. And as you make these calculations, be careful, if you're doing this in your calculator, be careful to put parentheses here and here. You want to close off your numerator in parentheses. You could just subtract 195 from 202 and use that value, so you could do that ahead of time. Or if you do it all in one step, you need parentheses around your numerator and possibly your denominator as well. And when you do that, you'll find that the test statistic you come up with is 1.68. Now we have a right-tailed test, and so that means that you're going to put the critical value right here. All of the alpha, 0.05, is in the right tail, and so you put the critical value of 1.69 here. And then the test statistic we came up with was 1.68. So that is, even though it's just barely, it is actually to the left of the critical value, and it falls under the fail to reject region. And now we go back to our flowchart to determine our final conclusion. Now, if you recall, the original claim did contain the condition of equality, so this time we follow this direction on the flowchart. And once again, however, we're asked, did we reject the null? And no, we failed to reject the null. And so our conclusion is worded, there is not sufficient evidence to reject the claim that the mean weight of airline passengers with online baggage is 195 pounds. Now notice that it says there's not enough evidence to reject the claim. It doesn't say that we have found that the claim is definitely true and supported. It just says that we can't say it isn't.